Hi, in this tutorial we're going to do a aim practice game with cool animated UI widgets using material blocks. So if you want more videos like this, don't forget to like, subscribe and share. And if you want to access the code or the assets of this tutorial or looking for help, you can check our Patreon in the description. Let's continue the tutorial. Hi everyone, in this tutorial we're going to do a aim practice game. So I'm excited about this one because we are going to use the new material block and we're going to do animated UI using materials, and I'll show you how to do that. So in the end, basically our entire UI will look something like this. Of course, so we'll have so this is actually not visible on this one since this is a bit static, but both of these are materials, and actually there's even more to this timer material, and I'll show you that in a second. So this is a aim practice device. So we have so this is the manager device that's going to manage many aim practice games that you might have in a aim edit build kind of map. So it manages all those, and it also has many options on it to customize the UI, right? And what you do is you set the aim practice games. So you for each aim practice game you fill a class in here. So you fill an element in this array, and so this is a kind of a generalized way of doing it. So this device allows you to manage many different kind of aim practice games. So for an example, I just set up an area like this, but the idea is that by using this layout, you can actually set up a different kind of aim practice games. But most of them, the common parts of them are, they all have a name. They all have a duration, second. And they all have a start button, stop button, and a guard spawner or NPC spawner. I mean, both of these are optional, so you can set either or both. It's up to you. And then we have spawn location props. So basically, the guards or the NPCs will be spawned through the location randomly through the locations set by these props. So I have this area which and then we have the accuracy volumes, but they're in a separate array because they're not per game, they are for the entire island. Basically an accuracy volume, what it does is just if the player is in that volume, we are going to display the accuracy widget, and we'll also track the accuracy only if the player is in that volume. And then we have the reset accuracy buttons. You can set these in any place in your map, so that's an array, and when the player interacts with any of these buttons, the accuracy of the player is going to be reset. So this is how you set an example of an accuracy an aim practice game. So here we have also hit detect triggers. This is and again just one array because we don't need to keep them in a per practice game structure. So basically we need to detect the hits, so we can detect them when they are on a NPC, but to detect them when they're not on the NPC, basically you set up an aim practice game area like this, a volumetric area I did it with an invisible barrier device. And basically you open an area to shoot, and all the other sides of that volume is going to be filled with triggers that are only going to detect hits. So you need to set them activated by anyone, make sure they're not visible, and then also set receive damage when invisible. That should be also checked. Make sure it's not showing any effects, and it should only be triggered by damage and nothing else. And actually, make sure you cover all those walls and stuff. Actually, I could have set I could have actually put hit detect triggers on the floor as well, but not going to do that right now. It's not important for the purposes of showing it how it works. And then of course we need the player spawner, to initialize stuff. And I'm not going to I'm not going to go through all these UI settings. I mean, by default the UI offsets are set like this, and you can change all of that. You can play with the text colors and stuff like that. It's all up to you. So let's come to the important stuff, the materials, right? So we are going to use this MI target to show the accuracy of the player. So when the accuracy is 0%, it's just going to be shown like this, a empty circle. When it's 100%, we're going to show a full filled target. And when it's 50%, it's going to be halfway filled. Yeah. And for all the other values in between, it will show something in between. And this is a material parameter, but you don't need to set this. So this will be set by the verse code, or according to the accuracy value of the player. The verse code is going to set this at runtime. And then we have the timer. So this is a pretty cool one. So it just oscillates to left and right. And so this B small time left and time left normalized, these both are going to be set by the verse device, by the verse code. So you don't need to touch those, but you can like change the shake speed and stuff like that, or the amplitude, right? You can make it, it will, even a little change in the amplitude is going to increase the shake a lot, and rotation speed, stuff like that. You can set all those. And so this has two modes. So when the small time left is 0, this is set by the verse device, so you don't touch that. But when there's small time left, verse device is going to set this to 1, and it's going to instead of oscillating left and right, it's going to shake vertically in a fast manner. And then also as this time, and it will also decrease this value, and it will start flashing in red, in a red kind of a red color, and you can actually change that flash color to anything you want. So that's actually pretty good. And as I said, those are going to be, these two is going to be set by the verse code. So all you need to do is just set these. And that small time left, that's also set by the verse device. So this is the timer widget, small time left threshold seconds. So that's a long name, but that's what it is. So when smaller than 10 seconds left, it's going to shake vertically. But you can set this to anything you want. And actually, let's come to and one other thing, you're not setting the textures and materials through editables this time. So you need to put the materials in a folder called materials, and then also put the textures in a folder called textures, right? in here. So I have also other textures from other tutorials, but you get the deal. Because let's come to the code now, because that's how we access the assets. If you come to materials dot, you can see those, right? And if you come to textures dot, you can see those. Okay. And I'm actually going to show how we implement these materials as well. So these are just user interface materials and masked. I mean, this one is masked, but yeah, the other one is masked as well. So we have a texture that is a target texture, and then we have the same texture, but a bit different. It's just not filled, right? This is the filled version of it. So basically, this actually not used. It's an old thing. All right. So this material is simpler than the timer one. So this just has a fill parameter which is set by the verse code. Okay, it's taking a bit. And so this is an offset to because we are subtracting this 0.5 offset so that it doesn't overflow. So basically we get the current UV coordinate, and then we get its length. So we get the radius of it, right? And then we divide it by half. It's again, it's because this length is going to be something higher, some value that is larger, so greater, so it's going to overflow. So we need to cut it down, and then we basically using that step, we lerp the textures, and we also lerp the alphas of those textures as well, because we need to shift the alphas as well. If we were to use this alpha, then we couldn't get the colors inside, and if we were to use the alphas of that, then we would get some black color inside. So actually we are defining a radius determined by this fill and this calculation. So let's say when it's 0.5, it's something like this, right? Actually, let me fill it. So it's defined this radius. So between this radius, it's choosing this texture, and outside of that radius, it's choosing that texture. That's straightforward. And then we come to the timer texture. It's a bit larger. So first we have the rotation, the left and right oscillation. So we use the time node, and we put it the sign. So you'll see that pattern a lot when you want to do something periodic with the material. So basically, the only thing you can use as an input when you want to do something animating or moving, you need to use the time node. That's going to give you a changing time value as the time goes, and then when you want a periodical movement with it, and you either use sine or you can use cosine, which will give you a value between -1 and 1. So basically we get a changing gradient based on the sine value. So this is like what like cosine rule. I forgot. Like basically we are calculating from the radian. We are calculating the offset that we should basically calculating the rotation offset. We are rotating the texture coordinate, and then you get this rotated UV. And then again with the timer, so now we need to, as you can see, it's not just rotating, it's also shaking while rotating. So we get that rotation, and then we add the shake on top of it. Again, just sine and time. This is just so this one is doing a vertical shake, and I thought I was doing horizontal, but okay, so this one, yeah, all right. So this one's the vertical shake, and this is the shaked YUV. So if small time is left, then it's going to here it's going to, by multiplying, it's going to choose the shaking version and not the rotating version. But depending on the value of this, outcome of this is going to change. And then we give that UV to to the UV input of the texture. And then this is just for the color. So depending of the value of this, we're just selecting this color or the texture's color, which is you could have just, if this wasn't if you wanted a different base color for the timer, you could actually just use the alpha on the opacity mask, and instead of using the RGB here, you could you could just use another color value and then plug it in here. So you would, as the base color of the timer, you could have something else. Or maybe if you had another, this is a mask texture basically, but if you had a like a pattern texture or a base color texture, you could use that as well, not just white. And that's it actually. That's it. Okay, that's about it. So this little Boolean value here, not Boolean, it's actually float, but we use it as if it's Boolean. It allows us to choose between two behaviors for this material basically. But we have the instance version of those to easily change the parameters. And now, of course, all these assets will be available to you on our Patreon, to our members, to our elite members, and anyone through the Patreon shop. So definitely check that out if you're interested. But you could actually, if you have your own textures, you can do these materials yourself as well. I'm guessing it wouldn't be too hard to do the timer, because you could find a similar timer texture, but maybe not the target one, even though its material is simpler. Anyways, so let's continue with the code. So we define the textures, and we also have a note for you again as a reminder. And of course, this one uses persistence. And that's another important point. So when using the persistence to store the score per aim practice game, we are using the game name. So make sure no game names are the same, so they won't collide. And make sure when you set a game name, don't change that. If you change it after publishing your game, you can change it while developing it, but if you change it after publishing your game, then basically the players will lose their saved value. Maybe if you want to change the game, you can if you want to change a game name, You can change the game name in a separate way, in a where you display it on a billboard device or on UI or something. Just change it on the display part of things, but make it stay the same on here on the device. So yeah, that's how we do it here. We record the eliminations, and the accuracy and the score per game. In the agent data, we have the same stuff, and then we have other states to handle the current game, and then the UI. And this is a helper struct to set the offsets of the UI elements and stuff. But by default, it's going to be set up nicely. If you want to change that, you can play with these values here. But one detail is that the size here you set, if it's a text widget detail, the size won't change anything. So I just set it to 0. But if it's not a text like this, then the size will, set the size of that widget. I already showed these. So each aim practice game, listens to their own events, and then they call the main device. Here we also have a information text log for you. If your teleportation props are in a place that is stuck, then teleportation might fail. So that's that's more information for you. We have a bunch of editables again, all for setting up the UI. I already showed these. And then we just have an agent map, and we have checking if we have a state to control if the game is active or not. Then for all these devices, we subscribe to the events, and then we run this async tick per frame. In this, okay, so let me show you the async function first. So here we actually run the timer and we update the UI. So that's all we do. And on the hit detect trigger, we just, if it's in a volume. And so another thing, a trick we do is that on like aim practice games, usually if you use a shotgun, it's going to count like multiple times for each bullet. But by doing this, by allowing only one registration per frame, we're actually kind of eliminating that. So we are not counting bullets, so we are counting shots, right? Even if it's a shotgun. Shots fired, and then we allow for a hit to be registered a frame later. Oh, actually, okay. Oops. So I actually need to I forgot to add a sleep here, so it wasn't doing it one frame later, it was doing it immediately. So actually it's good that I catch that, right? All right. So we have it on player spawn, we initialize the player data, then we initialize the UI. Pretty straightforward stuff. In here we reset the accuracy, we're saving the data, is setting the UI state. So on the game start button interacted, we are basically starting the game. So even if there was any other game active, we are just overriding it and we are updating the UI. And on the game stop button, we just stop the game. So when the agent is when the player is in accuracy volume, so we are we're tracking that, and we are only showing the accuracy widget when the player is in an accuracy volume. Basically, if you want the entire, if you want that accuracy widget to be shown in the entire game, then you would basically just put a giant volume. So this is when an NPC is damaged. So this is where we also, track the hits. And when a target is eliminated, since we are tracking the lifetime eliminations as well, we're increasing that. And then we are also increasing the, score for that game, for an active game, if there is any. And, we are saving that data, and then we are updating the UI. So this is our little save data function for persistence. So make sure that you are always checking is active when saving to a persistent, when accessing actually to a persistent agent map, because if you are not, then it could actually crash at runtime if that player has logged out. And actually, let me make sure that, we are also checking it here. Okay, that's cool. And then we come to, conversion functions. Then here a bunch of widget state. So these are just, using the agent data, updating the UI, all boring and straightforward stuff. Nothing really interesting in here. Here, so we do a little bit of formatting, and also in timer widget state, we also do a formatting, but not this function itself. We have a format timer text function here, which does a basic formatting. So it just, if it's like 20, basically it formats as if like 25.4 seconds. It just puts one number after the decimal point. Again, just a visibility function that just updates the visibilities of the widget. And this is the canvas creation function. So it's just through using all those widgets states, it creates the widgets. And this is a timer material. Hey, we're using material block. So we're using material, and then we're using its size. Then text, and then we have the target material, or accuracy material, right? We have text for those. And then for elimination, for best score, for current score, we have a widget, and on top of the widget, then we have a text. And that's all we do. And then we return it. So that's all for the code. So let me scroll up slowly so that you can see it. Okay. Okay, I did a bit fast this time, but I think you could manage to slow down and see it. So actually, since we have updated our code, let's push our changes, and I'm going to pause the video, pause the recording, and then I'll continue from the game in a second. Okay, see you there. Okay, so we got our game running. So I'm just gonna take an assault rifle from here, and as soon as I enter here, you can see the accuracy widget on top, and it won't, and nothing will happen because there's no triggers here. But as soon as I start shooting here, you can see the accuracy setting immediately to 0 because you don't have any shots. But I can slowly increase my accuracy like this, and you can see also my lifetime elimination is increasing. So you can also see that they are kind of stacked on top. You can do a lot of things here. So you can you can fill this volume with like this barrier volume with bumpers, jumpers, damage volumes, all kind of stuff, right? And you could make this more challenging. Of course. So let me start the game so you can see the timer is going, and as I'm eliminating the NPCs, you can see my score increasing. And I can actually stop anytime. If I start again, you can see my best score is stored. even if I just stop it. So you will see as the timer goes below 0, so it already started flashing actually, and when it hits 10 seconds, so it now shakes vertically, and now the game has ended. Okay, and also saves, so let me show you that as well. So we had what, 26 elimination, right? Something like that. So we had 26 eliminations, and we have 26 currently as well. That's awesome. So yeah, let me get my gun. Oh, okay, and I'm going to show you the accuracy resetting as well. So when I come here, you can see my accuracy is recorded as well, and as I'm shooting it, it continues where it left off, and you can see my best score was saved as well. And I can just come here, hit reset accuracy, and voila, it resets it. I can use another button as well, it's just an array filled with buttons. And so this device gives you a really powerful starting point to set up a really big aim practice game with different kind of aim practice games in it. You can do really cool stuff. And that was all. To access the code or the assets of this video, you can check our Patreon. So thanks for watching. Like, subscribe, and share if you enjoyed, and also leave a comment on what story you would want to see next. See you later.